Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. So this is part 5 with discussing with MCQ on metal cutting. So for continuation of the MCQ questions, so subscribe for upcoming lectures onto the some of the MCQs onto in detail with the metal cutting operations with the lathe machine, drilling machine, milling machine, shaper, planer, slaughter, grinding, etc. for all kind of conventional metal cutting operations. So now in this video, starting with the first question, crater wear is mainly due to the phenomenon known as first, adhesion of the metals, second, oxidation of the metals, C, diffusion of the metals, and D, all of the above. For detailed study of the crater wear, you should find the link in my description. So just you can see. So in case of the crater wear onto the single point cutting tool, just you can see the single point cutting tool. So this is the tip of the tool which is physically in contact with the workpiece material. So workpiece is being rotated and tool is fed against the rotating workpiece. So all the chips it will be flowing onto the top face of the single point cutting tool, or you can say rack face of the single point cutting tools. So due to that, high heat is being developing at the tip of the tool and basically onto the chips. So 70% chips will be carried onto the chips. So these chips it will be having a micro welds onto the that top face, or you can say rack face of the tool, and due to that micro welds, the diffusion take place onto the face of the tool, or you can say rack face of the tool. So due to that diffusions of that micro weld, or you can say some materials it will be diffusion onto the top face, and due to that diffusions the top face it will be weared out, and that will be called as a crater wear onto the single point cutting tool. So in case of these questions, crater wear is mainly due to the phenomenon known as a diffusion of metal. So the answer C. Then next, the shear velocity is the velocity of, the option is tool relative to the workpiece, not possible. B, chip relative to the tools, not possible. C, tool along the tool face, it will be also not possible, and none of this. So this A, B, C is not possible. The shear velocity is the velocity of none of the above. So the answer D, none of the above. The next question, the lead screw of lathe has which type of threads? So basically application of lead screw that will be providing the constant feed during the thread cutting operations. So if it will be the requirement of the constant feed, or you can say constant feed mechanism for the cutting, so that will be the single start thread, because according to that different kind of thread geometry, if that will be the lead is equal to pitch, so that will be considering as a single start. So for that continuously feeding mechanism, always requirement of the lead is equal to pitch. So that will be only possible in the case of the single start thread. So single start thread it will be used in the case of lead screw. Then fourth, the cutting fluid mostly used for machining alloy steel is first, water, B, soluble oil, C, dry, and D, sulfurized mineral oils. So basically for working onto the alloy steels, so that will be the sulfurized mineral oil is being preferred for the cutting of such kind of materials. So the answer D. The next question, question 5, crater wears leads to increasing in cutting temperature, weakening of the tool, friction and cutting force, and all of these. So just you can concentrate here. The crater wears we already discussing into the first one. So all the chips it will be flowing onto the rack face of the single point cutting tool, and the crater wear it will be possible. So due to the increasing into the temperature, because that will be making a frictional force, or due to that frictions it will be increasing the temperature. So increasing into the cutting temperature is possible by the crater wear. Second, weakening of the tool. So by that crater wear, that will be reducing that length. So according to that, the weakness is possible into the tool. So weakening of the tool is also possible. And third one, friction and cutting force. So due to that continuously flow of the chips onto that rack face, so that will be also developing friction and cutting force. So option C is also possible, and D, all of this. So all A, B and C is possible. So the answer is crater wear leads to all that things. So all of this. Then next question. Negative rakes are used for carbide tools, heavy loads, harder materials, and all of this. So basically in the nomenclature of single point cutting tools, there are three kind of rack possibilities: zero rack, negative rack, and positive rack. So basically for zero rack it will be applicable for thread cutting operations, and most of the cases for ductile materials it will be the positive rack angle is being used. Now the question is, negative racks are used for. So if you want to cut harder material, so that always adjusting with the negative rack angles for the cutting. So here that will be the option C, which is harder materials, the negative rack angles are used. So option C. Next question. The negative rack is usually provided on which material? So as we already discussing, for cutting of harder materials we always prefer the negative rack angles. But which kind of tool material is being used? So generally cemented carbide is being selected for cutting of harder materials with the negative rack angles. So first that will be the high carbon steel, so not possible. B, high speed steel, HSS, not possible. Cemented carbide tools. So the option C, cemented carbide tool is being preferred with the negative rack angles for cutting of the harder materials. So option C. Then next question. In oblique cutting of metals, the cutting edge of the tool is perpendicular to the workpiece, B, perpendicular to the direction of the tool travel, C, parallel to the direction of the tool travel, and D, inclined at an angle less than 90 degree to the direction of tool travel. So for detailed study of difference between oblique cutting and orthogonal cutting, you should find the link in my description. So basically in case of the oblique cuttings, that will be having a inclination of angle. So inclined at an angle which is less than 90 degree to the direction of the tool travel. So the option D is preferred. Inclined at an angle which is less than to the direction of the tool travel. Then next question. An important geometrical quantity in the cutting of the metals which can be used as a criteria for machinability of the metals. So first one is the cutting speed, feed rate, shear angle, and tool geometry. So by these options, the cutting speed, feed rate, and tool geometry, that will be the parameters. But the shear angle, that will be an important geometrical quantity in the cutting of the metals which can be used as a criteria for machinability. So the option C, shear angle. For detailed study of the machinability and how to find the shear angles, you should find the link in my descriptions. Then last question. In hot machining, the tool is made of tungsten carbide, B, brass or copper, diamond, and stainless steel. For generally hot machinings, it will be having a higher characteristics material as a tool material. So basically that will be having a higher melting point of the tool materials. So here that will be the brass and copper, which will be having a lower melting point. Stainless steel having a lower, and a diamond it will be also lower. But tungsten having a higher melting point. So this material it will works at a higher temperatures. So in case of hot machining, the tool is made of the tungsten carbide materials. So generally tungsten having around 300 degrees centigrade boiling point, or you can say melting point. So tungsten carbide is used as a tool material in a hot machining process. So this all regarding for the MCQ questions on the basic metal cutting processes. If you like this, then subscribe and share more the mechanical engineering tutorials. Thank you so much.